Today, we'll synthesize potassium chromate, a useful oxidizer in organic chemistry, for the oxidation of alcohols into ketones or carboxylic acids. It is also a precursor to PCC, an oxidizer that turns primary alcohols into aldehydes. Warning: potassium chromate, as every chromium 6 compound, is classified as a 1A carcinogen, meaning it is carcinogenic to humans. Be very cautious while handling it. Potassium hydroxide is corrosive, and potassium nitrate is an oxidizer. With that out of the way, let's get on with the synthesis. The three reagents we'll need today are 60 grams of chromium 3 oxide, 88.62 grams of potassium hydroxide, 120 grams of potassium nitrate. We'll start by adding potassium hydroxide to a steel pan on top of a gas burner. Then we'll turn on the gas stove and start melting the hydroxide. When the hydroxide melts into a uniform liquid, we'll start adding the chromium oxide, then stirring it into an homogeneous mixture. As the slurry gets uniform, we start adding the oxidizer, potassium nitrate, in portions. The mixture will eventually start changing color from green to dark yellow, and it will bubble because of the release of hot steam produced during the reaction. In this reaction, potassium nitrate is the oxidizer. The nitrogen of potassium nitrate gets reduced from oxidation state of 5 to the oxidation state of 3, while the chromium species gets oxidized from oxidation state 3 to oxidation state 6. Then the mixture is allowed to cool down, resulting in a solid mass of reactants and the final product, potassium chromate. When the solids are near room temperature, we can start adding water to dissolve the product, along with the impurities, which will mainly be potassium hydroxide, nitrate, and nitrite. We can thus start heating up the mass to dissolve everything. When everything has dissolved, we can begin filtration. So we set up a cotton plug funnel on top of a flat bottom flask. Then the solution is filtered through, obtaining a clean, deep yellow liquid. The solution is then heated up to a boil in the same clean steel pan to evaporate water. This liquid is then poured in a beaker to crystallize, which, upon reaching room temperature, is covered with plastic wrap and placed in a fridge to cool down, resulting in more precipitate forming. The impurities of this synthesis are potassium nitrite, potassium nitrate, and potassium hydroxide. The solubility of these impurities are higher than the solubilities of potassium chromate. Thus, potassium chromate will be the first salt to crystallize out of solution. Thus, the crystalline mass should be relatively pure. The precipitate is then filtered in a Buchner funnel, and the filter liquor is stored in a glass bottle for storage. This will be used as an impure source of chromate for later projects, like the synthesis of chromium 3 salts. The filtered and now dry chromate is weighed and stored. The yield comes out to be 21.84% of reasonably pure potassium chromate, although there is much chromate left in the filtered solution, so the yield could be much higher.